The hardware for the automated braking system consisted of an ultrasonic sensor to measure distance, an Arduino as the microcontroller, a servo which is connected to a brake lever that applies the brakes, an external battery, as well as a voltage regulator. Compared to the prototype, the new sensor is more consistent in its readings, more durable, and weather resistant. The housing for the sensor also makes it much easier to mount to our completed aeroshell. On the aeroshell, the sensor will be placed about 16 inches off the ground. A selfie stick was used to achieve this relative height. The servo mounting base was kept the same as the prototype. We upgraded the servo so that it is more capable of applying greater force. The new servo can produce roughly 500 ounce-inch at 6 volts. For test 1, we used a 17-foot long driveway at a decline of 2 degrees with an obstacle at the end. The objective for Frostbite is to recognize the obstacle and apply the brakes before making contact. Frostbite was able to detect the obstacle and apply the brakes, but not soon enough to prevent contact. We decided to tighten the brake lever, allowing the brakes to be applied sooner. For test 2, Frostbite was able to come to a complete stop before making any contact. It also leapt about 8 feet of clearance. With the incline, Frostbite was traveling at about 1 mile an hour in both tests. The servo was calibrated several times to ensure its capabilities. An external battery was attached to ensure the servo was receiving its optimum voltage. The sensor was also calibrated to ensure it was producing the correct readings. Overall, the automated braking system attached to Frostbite is capable of detecting obstacles in its path and automatically applying the brakes, providing safety to its environment, the driver, and itself. Further testing will include braking at higher speeds and greater loads.